This is a conversation with Thom, a 23-year veteran at D-Wave, one of the first companies to build and commercialize quantum computers. With a background in engineering, physics, and deep ties to the AI community, Murray explores how these technologies intersect to solve real-world problems like demand forecasting and scheduling. I loved how he connects the frontier of quantum computing with practical business impact, starting with the challenge of making quantum as accessible as AI today. Hi, Maureen. Very nice to meet you. Thanks for joining the Humans and AI podcast. So, I love your story. I've been checking and researching a little bit about you, but so let's get into it. So, you are the VP of Quantum Technology at D-Wave. I saw that you've been like over 20 years at least there working. Could you share a little bit of your background and how, yeah, you've been long time there from 20 years for me. It's like you've been your whole life there. So would you let me share a little bit about how was the journey to all that, to all that time and all your experience in this company?
Yeah, thanks, Flori. But it's a pleasure to be here. And yeah, in fact, I just celebrated my 23rd anniversary with D-Wave. And my background, so I did a degree in engineering physics, which is like electrical engineering and physics. And so I was really fascinated with applied technology. How can we take scientific knowledge and then put it to use so that it can do useful work for us? And in particular, I was really fascinated with the idea of building computers from scratch. From an early age, I learned about computers from my father. But by the time I graduated from university, constructing computers was a well-solved problem. And as I learned about the idea of using quantum effects to accelerate and perform calculations that are too slow or too hard to do with classical computers, that idea just made sense to me. So I was really drawn to the application space for all of those reasons.
Nice. I myself, I have to be honest, I don't really know a lot about quantum computing because right now all the hype's about AI. But in the past, I know that quantum computing was a bit not bigger, but I think people knew or were more interested in it. So, why do you think this is that it's changed or it's not as well known as AI right now?
Well, I think that technologies grow through these explosive growth cycles when something very powerful becomes really easy to use. In my experience, because there's a very close technical connection between quantum computing and artificial intelligence, I've been working alongside the AI community for more than a decade. But I think that once we got to a point where it started to become like a very household type of tool for text based queries, that just broadened its applicability. I would say that, like right now, what I'm finding is that a lot of businesses are trying to learn how to get a competitive advantage in this very fast changing ecosystem. And they're asking me, how does quantum computing relate to artificial intelligence? And then also, you and basically, the answer to that is that it's a computing platform. It's meant to perform calculations that classical computers struggle with. And that can be useful for AI in both in terms of like can be useful for, let's say, a direct optimization in artificial intelligence, which usually the AI community considers to be two sister fields. And a lot of businesses are curious, how do I tell the difference between an AI application and an optimization application? And really what I try to help them understand is imagine you have a task in a hospital and you're trying to hire a new employee to do that task, how would you train them? So if they're going to be looking at medical images and they need to classify if there's healthy tissue or unhealthy tissue in the images, then you're just going to give them lots of like training images and say, I need you to learn how to detect the difference between these types of images. That's a good learning from data example. That's classic AI. That's how AI systems are built. But let's say instead you were going to have that new employee schedule nurse vacations. In that scenario, they're going to meet with a hospital administrator, and that administrator is going to say, I have a series of rules that you schedule these vacations by. You have to make sure you take into account their seniority, their preferences. We have to make sure we have enough nurses working on the ward. We have to keep track of the shifts that they're working, and they can't work morning shifts after night shifts. AI has a really difficult time discovering rules in applications. So that's a great optimization application. And we have customers looking to use our quantum computers for both of those types of applications.
Do you have any use case from the web that you could share with us to understand how you guys help your clients?
Yeah, absolutely. So let's say if we're thinking about the intersection of quantum plus humans and AI in this context. So there's two ways to think about it. One is a way where AI and quantum computing systems actually share different parts of the task, and a second way where it's like they actually work together on the same part of the task. So one example would be Pattison Food Group, which is a company that owns 13 different grocery brands here in Western Canada. So in their business, they use AI to learn and predict. They study historical data about how much demand they get by each day of the week and each week of the year, and they use that to forecast what their expected demand is going to be in their grocery stores. And then they use our quantum systems to optimize the creation of new schedules to meet that demand. So that's a really challenging problem because they've got a variety of employees who are working within a particular grocery store, and they have training to work in some locations and not others. There's a lot of rules around building work schedules. And so we were able to do that, help them quantum optimize that solution. They've now taken that application to production as well as a second application, and they're expecting their workforce to save 50,000 hours every year from that improved optimization. So that's really a good example of even in traditional businesses that are not necessarily recognized for super bleeding edge tech, it's really actually quite easy for them to build applications that have a positive impact on their workforce, combining AI and quantum to basically solve their business challenges. And then let's say to contrast that grocery store example to, let's say, a pharmaceutical example, Japan Tobacco's pharmaceutical division is looking to actually combine the technologies together. So they want to improve the AI methods that they have for discovering new potential drug candidates. And they have found a way to hybridize that where they've been working closely with us, incorporating our quantum computer in their machine learning workflow. And that has actually helped their workflow produce a higher proportion of valid drug candidates. So there's both those kinds of ways. And those are two examples of the way that our customers are using AI and quantum together.
Great. So, in your experience, which you have a lot, and in your opinion, how has been the progress of quantum computers in recent years?
I would say it's been very surprising for folks because the performance and the capabilities and the ease with which people are programming them has been progressing so rapidly, it's actually surprising people. We have multiple customers who are using our technology, our quantum computing technology in the cloud for their businesses, just like those examples I just provided, as well as, let's say, in the telecommunications industry and the automotive manufacturing industry. And one of the, I would say, most like greatest developments in quantum computing in the last year is that we were able to do a performance test on an application in material simulation. So we had a candidate of a set of magnetic materials, and we were trying to determine their properties. And we compared what our quantum computer could do relative to one of the world's largest supercomputers. And what we were able to determine in this test, because this was a well-studied problem. It was known to be very difficult, and we knew exactly how the difficulty would grow as the size of the material sample grew in the tests. We were able to determine that for the supercomputer to compute its properties in the tests instances that we used would have required as much electricity as the world uses every year. And we were able to do those same calculations on our quantum computer using less than $1 worth of electricity. When I tell people that, like that's the magnitude of the difference between classical computing and quantum computing, they're totally surprised by it. And that just happened this year. So there has been a progression in, we've been releasing 6 generations of quantum computers since 2011, and there's been a progression in their capabilities, but that has gone from like our very first prototype to dramatically outperforming a supercomputer in energy efficiency for compute in what is like a decade or 15 years, and catching up to all of the classical computing industry. So I think that when folks find out that like they don't need to know quantum mechanics to program it. In fact, a small team of developers can build applications with our quantum computing systems, and they can do that in a period of a few weeks or months. They're really excited to engage with the technology and find the places where they could take advantage of it.
Interesting. Do you have any company or leader in this quantum computing field that inspire you or you admire their job they're doing in this field?
So a company or a person who's inspiring me in the field, I'm always looking for patterns and lessons from people throughout the industry. Each of us has our strengths and weaknesses. So I'm always trying to learn from everybody that I'm working around in terms of what their strengths and weaknesses are. But the interesting thing is that at D-Wave, our focus is around making quantum computing technology powerful for our customers, but we can't possibly have as much expertise in those application domains as the customers themselves have. We're constantly learning from our customers in terms of how they're finding creative ways to use the technology. To use another AI example, there's a group of scientists at a local particle accelerator. To use a colloquial term, I'm not sure if everyone expected me to say particle accelerator in that sentence. And they're studying how particle accelerators at the Large Hadron Collider are working and how to train them using machine learning methods. And they're very consumptive of energy. And so what they've done is they've actually developed a way to use our quantum computers to generate synthetic data so that they can actually do a better job of training those models. I never would have expected that to be the case. And although I'm a technologist and I work in a technology field, it's what our customers are doing with it, the new discoveries that they're making, that really fascinates me. Because certainly as I'm talking with people, as I'm traveling to events around the world, I was just in Ireland last week, I was in Zurich and Helsinki the week before that. An absolute pressing concern as people are thinking about solving some of the greatest challenges the world is facing right now is the energy consumption that compute is taking up. And if we can find ways, now that we have basically been able to demonstrate very strongly that our quantum computers can do these really difficult calculations in this highly energy efficient way, then this is an exciting sort of Yukon gold rush of how quickly can we find ways to offload difficult problem sets from supercomputers onto quantum computers and dramatically change the power consumption profile of those applications.
Interesting. So I guess that there's no like a name to mention. That's what I meant. Do you you have someone like to mention the audience or even myself we could kind of check because you think it's a good person to follow in this quantum computing field?
I see. I would say in the quantum computing field. Okay, so to name someone specific, it would be Dr. Hidetoshi Nishimori. That's a Japanese name, Nishimori, from the Tokyo Science Institute, which used to be the Tokyo Institute of Japan. And he's unbelievably humble and it's so talented. And he working with one of his students, now Dr. Kadawaki, came up with the idea of how to use quantum effects to do useful work for us. And that has become the basis of an entire model of quantum computing, which is really bringing about near-term applications. And he regularly he's conducting science right now and publishing new results. And he's talking about like the frontiers of that field and what's possible to discover with quantum computing technology. So whenever I see one of his posts, I always find it really exciting. That would definitely be someone for people to look out for in the quantum computing industry.
Great, thanks. Because I cannot I have a lot of guests with every different industries, but I'm not expert in any of them, to be honest. So it's kind of always good to get advice and get some to get more deep in the things. So, in your perspective, what is the best balance between quantum, AI, and human? Yeah.
I think that's such a critical question that we're facing right now, right? Because we've got these emerging capabilities. They're very advanced. They're new to us. And so I think that a lot of folks have started to become a lot more comfortable with what artificial intelligence is capable of because they've had a chance to interact with it and they can get a sense for what its limitations. It's not capable of everything. And as we're moving forward, I've heard a lot of folks describe it as let's look at using artificial intelligence techniques to allow us to, as helpers, maybe as assistants, we'll make queries from them, but then there's still oversight, and we are the oversight for those AI systems. I think that we're looking at ways, I mean, there are going to be a number of things like text to text that AI systems are extremely efficient at. But there are some things, like I mentioned, in terms of discovering rules in how we operate that AI systems are terrible at. When it comes to making high dimensional decisions in dynamic environments, artificial intelligence systems are really poor at that. So I think that we can combine those technologies together so that just in the way that the Pattison Food Group did in their grocery example, where they're using AI systems to help them anticipate what are the needs of their customers going to be, and then using quantum computing to help them then staff and prepare their business to meet that demand. That's a great example for us to take inspiration from. And also, as we're looking towards probably one of the greatest challenges we're dealing with right now is that we have vast amounts of data at our fingertips and we're able to find it relatively quickly with search engines, but we're not doing particularly well at validating the information. So we're getting inundated with information and it's a lot harder to tell, is this real information or is this just sort of something that someone generated for fun? And that's because, we need to challenge ourselves with what is the way that we actually break down the process of validating information. And it turns out it requires logical rules. If this is true and this is true, then, in the way they're being constructed together in a logical argument, this other thing can be true versus logical fallacies where things turn out to be false. So that's really where quantum computing has its strengths. I'd also like us, and this is something we're doing at D-Wave, working with our customers, is exploring how we can combine quantum computing with artificial intelligence, so we can start to incorporate and maybe potentially impact more of those logical instructions, so we can do a better job of helping us differentiate true information from just made up entertainment.
Great. I also hear that one of the reasons quantum computing is not as famous or trending as AI is because, as you say, AI it's way more accessible, easy for like ordinary audience, like people who don't have any clue how it works. Basically, just it's like Google, right? You just ask something and they give you information. But for example, with in quantum, it's a bit more tricky because it's not as accessible for people with not knowledge. I hear that it's more expensive as well to build that, but that's I let you to explain that more than me. But that's kind of what I hear. In your point of view, what is the how could you make the quantum computing more accessible to people who don't have that knowledge?
Okay, so that's a great point, and that's actually a misconception about quantum computing. Although I have to say, I'll lay a little bit of blame on the quantum computing industry because a lot of my peers in quantum computing make the topic a little more complicated than it needs to be. For instance, like at D-Wave, we've got customers who are able to build applications in businesses in a few weeks or months. And the training courses for learning how to program them are just 1 week long. So if you know how to program in Python, you've got some high school math skills, then you can learn how to program quantum computers and start putting them into application. And we have been building first the toolkit, the software development kit is open source. So whether you're a scientist coming in at a low level or an application developer coming in at a high level of abstraction, you still have visibility on everything that's happening within that open source stack. And we have been building tools to show people like how do you do workforce scheduling with a quantum computer? That's an open source example that we have that's available on GitHub, for instance. How do you do production scheduling? How would you tackle problems of routing multiple vehicles who are making deliveries? Those are very understandable real world examples. And we have like open source codes that show people how to program them. I would say it's probably worth acknowledging the fact that in its technology development, quantum computing is emerging, right? So certainly for folks who are looking to use it in business, it's accessible and readily available. And it's about helping people to realize how accessible it is because it's available in the cloud. You can access it in 42 countries around the world. It's got 99.9% availability and uptime, which means that 24 hours a day, you can be programming quantum computers and getting answers back. That's it's not you're not necessarily going to use it to write a book report. So that's probably a slightly different level of accessibility. But it's important for people to know that particularly at D-Wave, we're building quantum computers where you don't need to know quantum physics to be able to take advantage of the systems. But if you're interested in learning more about how the machines work, what better way than turning that really mysterious quantum mechanical effects into useful work? Find out what it can do for you, and then use that to build your framework of understanding about the technology and what its capabilities are.
Okay, interesting. So every time I hear about quantum physics, quantum computing, I'm like, wow, that's difficult. Kind of a lot of maths there, but AI is not much more different. It's just like maybe you don't really need to know maths for using ChatGPT. Right. And so that's maybe make it more accessible to every single one. Okay. So looking forward, how do you hope that quantum and AI evolve in the next few years?
Yeah, I think that the technology, these sort of emerging capabilities, I talked to you about this demonstration of like magnetic material simulation where we were comparing it against a supercomputer. It's not just the energy consumption was radically different. It's also the time to do the calculation. It would have taken the supercomputer a million years to perform that calculation, and we were able to do it in 20 minutes with our quantum computer. So let's just reflect on that for a moment. We're building a vast amount of artificial intelligence techniques that are based on building, and training highly restricted neural networks so that we can accomplish tasks. And the reason we're doing that is not because that's the best way to learn, it's because that's what computers can currently do. So, now that we have this new computational capability that's made the impossible possible, what can we do with it? It turns out nobody knows the answer to that question because it's never been possible. Everyone's avoided it. But there's a lot of the technical skills that people use in artificial intelligence, which are completely applicable for using quantum computers. And we have basically looked at that, and we've actually generated a way where we can show people how you can use that same capability in blockchain. So you can actually use our computers, take the hash function step that classical computers are doing that's very energy consumptive, and you can replace that with a quantum proof of work. The blockchain still continues to function, but what's interesting about it is it consumes 1,000 times less power. What we're hoping here is that we're building toolkits that are available in PyTorch and scikit-learn to help people begin experimenting with how to combine those quantum computers with existing AI workflows that are at the cutting edge, and learning, okay, how does this change the capabilities of that AI system? And I'm hoping that will help us to develop new capabilities in artificial intelligence that we can find use for, and then understand them well enough that we can also mitigate whatever challenges we're facing along the way during that development. I'm a big fan of using AI for productive uses and also watching out for unintended consequences and really managing those.
Great. And what do you think about the role of the humans?
We're critical. I think we're at the center of all of us. If I have learned anything from looking at how artificial intelligence systems learn and also how quantum computing systems come to calculations, as well as, let's say, classical computers, it's just absolutely amazing how our brains work, how they're constructed, what they're capable of doing, like how much information they're able to take in and then synthesize and find patterns in. And we're self-healing. We're a creature that we create new versions of ourselves, and if we get injured, we heal ourselves automatically. That's remarkable. As a technologist, that would be unbelievably difficult to implement. So, absolutely, we're very much at the core, on the center of this interaction between quantum computing systems, classical computing systems, and AI systems. And we just need to think creatively. We need to interact with these systems. We need to understand them. And then we need to think creatively about how to pull them together so that they can contribute to our lives and we can contribute to each other's lives, right? We're a social species, right? How do we help each other? How do we use these technologies to help each other so that we can achieve, I think, some really positive outcomes for the human race and the world as a whole?
Nice, beautiful. So I've got one last question for you. You've been over 20 years in this journey of quantum computing.
Yep.
I would like you, if you want to share an advice to your younger self about what would you advise to him when he was younger? What is the tip that you would give it to that person when it started in this field? So now that you know you have all this experience, you've done all, when you have a lot of, yeah, experience. But so the experience that you have right now, what would you tell to that person?
I think that probably the important thing to keep in mind is that the future, what it lays out for you, is like a cone of uncertainty, right? The smaller the distance you move into the future, the more you understand it. The further you get into the future, the less you're sure how things are going to come out. And you don't need to worry too much about that. Certainly, I would not want to spoil anything by telling my younger self just how long it was going to take to build the technology, because not knowing is an important part of what makes the journey possible. And a lot of really creative, brand new endeavors come about because we're willing to try something and we don't know that it's impossible. And then it turns out we're able to figure out a way to do it. There are some things I wouldn't tell myself, right? We've got to leave some of that mystery unknown. But also, I think in terms of being more comfortable with that process, what it is to be building a brand new technology that's disruptive and to be successful for a long period of time is continually setting goals for yourself and then trying to get to your point to, can I communicate to other people and share with them that we learned a lot. We've been able to make a lot of progress, and we've got a significantly more understanding than we did before. Those turned out to be the critical steps that allowed us to progress. And it absolutely has been the case. Maybe we didn't know this, and we were proceeding without knowing this for certain. At D-Wave, it was very important for our organization to provide value to our users, to our customers, right? We didn't have the option of just continuing to do research for our own purposes or focusing on putting this into an existing application in the next 2 or 3 months. But we had to focus on how does this technology get constructed so that it brings value to customers. And I've seen lots of other folks who have lost sight of that, and it's caused their technology development to go in a direction that is spinning its wheels. I would probably just advise myself to hold closely to that principle of bringing value to people as quickly as you can.
Thank you very much. It's been a great interview, a great chat. I enjoy a lot. I think I've learned a lot about quantum computing right now, to be honest. Yeah, I have loved your advice. I think it's as well. I like that you're not like super controller, like and you need to know everything. I think that's very, very important. Maybe it's because I'm a bit more controller. So I'm like kind of admire that from people who let things flow. Thank you very much for joining the Humans and I podcast. Thanks for listening to the Humans and AI podcast. We are here to spotlight the people making AI more human, one story at a time. See you in the next episode.